So we had just started to talk a little bit about what De Morgan's Law was going to be about, and we're going to jump into it now. What's happening with this law right here, there is almost an identical situation when we get to chapter 3, but we no longer will be in set theory, we'll be working with logic, and we'll see very similar things. So I'm going to come in a little bit closer so you can see what's going on here. But we were just saying, or what was that this period that we were just saying that it almost looks like that, yeah. I am, I just did, yep, yeah. No problem. It is red and it is going. What we have, first of all, let me ask y'all this question. It's got this little apostrophe. So in parentheses, it says a, what's that symbol? In this case, it's union. So how do we know it's union and not universal set? Because it's between the names of two sets, okay? It's not universal set symbol equals. It's not about to define a set. It's telling me what I want to do with two sets, all right? So A union B, what word do we say when we see that? We say prime, and what vocabulary word does that mean? We're finding the complement. So, what does finding the complement mean? What's not included in this, but is included in the universal set. So it's the rest of the universal set that's not within here. Okay? So there's a bit of a temptation to say, well, maybe I just distribute it. And at first glance, it does look like they distributed it. Y'all tell me, is this too small for y'all? Because I can bring down my focus a little closer, but you've got it in front of you. Are you okay? Because I'm talking about things that look pretty tiny from where I stand. So, De Morgan's Law shows that rather than going ahead and finding the set A union B, and then looking in the universal set and see what wasn't included, and that would be the complement of that, you could get the complement of A by itself, get the complement of B by itself, so it looks like they distributed it, but they didn't, because what changed? The union changes to an intersection. And then likewise, if we have an intersection in the parentheses and we want the complement of that, we can take the complement of the two separate sets, but get the union of those complements. And that's what this exercise is going to have us doing. It's going to have us trying it both ways. De Morgan's Law says this will always equal this. Two different methods of getting the same thing. If I'm remembering correctly, so we're about to do this using this universal set, this set A, this set B, for both versions of De Morgan's Law, and see if it truly works out. I think that in your homework problems out of the book, that you have some things where you're asked to do the same thing. You're asked to do it both ways. So key here is they're saying verify that what it says on the left side is the same thing as what it says on the right side here. So you're verifying it. Verifying it means you got to do it both ways and say, well, I did get the same thing both ways. So are we clear on that? Okay? So, by the way, let's just check to make sure this makes sense. What would you be shading if you are asked to shade A union B and you have two sets that overlap? How do you shade union? What does union mean? Our options are shade everything or shade just the center section. What's a union? everything, if they're all coming together. So A union B would look like that, right? So the complement of A union B would leave all of that unshaded and would shade everything that's on the outside part of the universal set. Is there logic to that? Okay? So that's the one we're focusing on. So I could either find this A union B and then say, what's not in it? That's what this is saying. Or I could find what's in A prime, what's in B prime, and find the intersection. What do they have in common? So that's what we're up to. You see our sets. You see our universal set, our A and our B. I can go ahead and slide this up because I typed De Morgan's law again right there. So that's what we're doing. So I've split our workplace into two halves because according to De Morgan, this should give us the same thing, right? So let's work it this way, where we do what's inside the parentheses first. So I want to create the set A union B. We've done this a few times, correct? So I'm going to start off with my curly brace. And here's my A, and here's my B. How do you want to go about making that union? How would you put them together? Just go ahead and list everything in A. Would everything in A be in a union? We need the complete A, don't we? We need all the elements from A in a union. And then should I go ahead and copy the 10, 12, 14 from B? Why just the 14? Okay, does that make sense? So we've already got the 10, we've already got the 12, but we need to throw a 14 into the union. Well, that's not what I was trying to get. That's just the inside part of that parentheses. I actually over here want to come up with the complement of this A union B that I just created. How would I find the complement of it? Where will I look? I need to compare this to the universal set. And what am I looking for as I'm comparing this with the universal set? The stuff that are not in the universal set and here. So the extras. So I won't list the 10, will I? Or the 11, or the 12, or the 13. We got the 14. Actually, it might be easier to look at this one first and say, that can be better. It's got a 10, it's got an 11, it's got a 12, it's got a 13, it's got a 14, it's got a 15, but it doesn't have the 16 or the 18. So this is the complement for A union B. Is that bringing back? I know you've had a weekend that you may not have spent a whole lot of time thinking about complements and sets and unions and intersections, but is it warming back up? What do you think? Do you think that's an efficient way to work this? Okay. Well, De Morgan said there's another way to work it, in which case you can find the complement of A, the complement of B separately. So this time I want to, for this one, I just want to compare A to the universal set and see what's not there. So the universal set has the 10 and the 11 and the 12 and the 13 and the 14, but not what? What's the complement of set A? 14. Yep, 14. Okay. 14 and a 16 and an 18. Do the same with B. Slade, help me do B prime, please. Okay, so prime means the complement. So it means look at set B, look at your universal set, and list everything from the universal set that is not in set B.
11, 13.
Okay, hang on. Gotcha, I'm with you now.
15.
Okay, 15, is that what you said? Okay. 16, 18. So I've got the complement of each set separately. And according to De Morgan, now that I have those two complements, if I intersect them, I should end up with the same answer I had over here. Do I? Bless your little heart. What does intersect mean? I look at the two and see what do they have in common, right? Well, they don't both have 11s or 13s or 14s or 15s, but they do both have so. Do you see how I verified De Morgan's law here? I worked what he has on the left side of his formula. I used that method. I did it on the right side, and sure enough, they do match, right? If you were doing a homework problem that asked you to verify De Morgan's law, I would need to see all of this. And I like the way I've organized it. I kind of split a line between it. I said over here I'm doing A union B's complement, and here I did the complement of A, the complement of B, and got the intersection. And I would expect to see all of that work, and that would probably be one that I would just love to choose to put as my my homework check. Because there's some work to be done there. Okay? Now, De Morgan also had another law that dealt with the complement of an intersection. And we're asked to verify that one as well. So we are not going to do it however we want. We're going to do it according to what De Morgan said. So I need to slide down because we still need to see those sets, don't we? This time, De Morgan wants me to start off with what's that term? Okay, so somebody in regular plain old English, explain what are you looking for if you want to get the intersection of two sets like A and B?
The numbers that A and B have in common.
That they have in common. The word common is your key, right? So, Rebecca, help me. What do set A and B have in common that you see? 10 and a 12. Just a 10 and a 12, right? So, Campbell, to complete this side, I need the complement of this new set I just created. So I need to compare this. Well, no, what we need to do is announcements.
Today is Monday, September the 15th.
Left out here.
Please stand for the pledges and a moment of silence. First, the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Now the Texas Pledge. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible. Please remain seated for a moment of silence. Thank you, students. Today I would like to start off by reminders that you do here daily, but let's start off a good week with staying on task, remembering all of our policies, procedures, and remembering that you must follow them at all times. Remember, all outside doors on campus must remain closed and locked at all times. For your safety, never prop the door open or open a door for anyone from the outside. All visitors must check in through the front office. All students must remain in dress code at all times. IDs are part of your dress code, but may not be altered, damaged, or covered in any way. If an ID is lost or altered, a $5 replacement fee will be charged. Students, please remember not to leave these IDs in the locker room because you will not be allowed to go get them in the morning. Also, please Remember, no outside food or drinks are allowed in the classroom. Only allowable closed refillable cups and bottles are allowed for water. This year, we are not ordering DoorDash, Uber Eats, and other deliveries will not be accepted. Food and drink is limited to the cafeteria for breakfast and lunch. Please also remember in that we should all be helping keep our campus clean and showing respect to our custodial staff. These ladies and gentlemen work hard to keep our campus clean, and we would like you to help them. Throw food trash only in the cafeteria cans and not classroom cans. If you drop mechanical pencil legs, pick them up, don't fry them onto the floors. Please give Miss Sandy the space to run the floor machine during the second period. She keeps our hallways looking nice and shiny. Thank you so much for doing your part to keep our school looking great. In addition, on a dress code, let me add that remember, hoodies are allowed to be worn, but you may not have your hoodie on your head. I must see your ears at all times. That is for the classroom and hallways and while you're in the building. Also, no pajamas, house shoes, or blankets are allowed. Please keep that in mind. This is a no device, bell-to-bell campus. Phones, earbuds, personal devices, smartwatches must remain turned off and put away from the moment you enter the building until you leave the building after dismissal. Please remember that it's after you exit the building. Okay, a few other announcements. High school student council, you need to turn in your forms and dues by today. Today is the last day for student council forms and dues. An announcement from Coach Huff. Remember that tonight is Bible Club. Bible Club meets in Coach Huff's classroom in B Hall at 7 p.m. Keep in mind that Bible Club meeting is every Monday night at 7, and that is for grades 6 through 12. We would love to see a large participation in our Bible Club. An announcement from Ms. Monzo of the National Honor Society. There will be a blood drive this week on September the 18th. That is Thursday. NHS is hosting their first blood drive of the year. Again, that is this Thursday, September 18th. You can get a sign-up form from Ms. Monzo between classes only. 16 and 17-year-olds need parental consent if it's your first time giving. So if you plan on giving, please make sure that you get that parental consent before Thursday. Let's have a successful first blood drive. A few reminders, this is a very busy week. We do have a junior high volleyball game at home this afternoon at 4:30. Students, with that, keep in mind that everyone must exit this building at 3:25. If you are going to stay and watch the volleyball game, you must exit the building and you must pay for student re-entry and come in when the doors open for that volleyball game. There's also a Lady Pirate volleyball game at home tomorrow. Teachers, the right way screenings are at admin office on September 17th. Please make sure you're scheduling that if you are interested. There will be a junior high pep rally this Thursday as well. Keep in mind that we will be on regular bell schedule on Thursday, and that junior high pep rally is at 2 p.m. and that will be for junior high only. Junior high only. Friday, we will be on pep rally bell schedule for a high school pep rally for our home game. All right. We will also be sending home Duchess and Duke and King and Queen, Prince and Princess homecoming forms today for students who are on court. So be looking for those to come to you if you are on court. Okay, I think that is it for today. Have a great Monday. Thanks.
All righty. Campbell, didn't forget. So we have a very small set for the intersection. So the complement of that set may be kind of long. So what would go in that complement? Okay, what did you say after 13, 13? Uh-huh. Uh-huh. Okay. So, whoa. Did you say 12? Huh? Okay, but 12's in this guy. So, we don't want the 12, right? So 11, 13, 14, 15, 16, 18. Y'all back that up? Sound right? Okay. So, that's one way to get it. Find the inside set first, and then compare that set to the universal set. Or we're given the option of finding the complement of each set on its own. So Stephen, help me find the complement of just A.
14, 16, 18.
Okay, 14, 16, 18. Do y'all back that up? 14, 16, 18? Who can back that up and say, yeah, I know for sure? Okay, not sure what some of those sounds were, but I'm going to go with that's the backup. All right. So, let's see. Cheston, can you help me find the complement of B?
11, 13,
Yep, keep it going. 15, 16.
Please find this interruption. I would also like to add an announcement for homecoming court. Remember, students, each homecoming court candidate is allowed to hang 2 posters in the hallway for homecoming voting. 2 posters. They must be approved by the front office before you hang them. Junior high homecoming posters can be hung in A hall once they are approved, and high school homecoming posters can be hung in B hall once they are approved. Now, for your handouts, or your little candy and trinkets that you want to use for campaigning, those can only be handed out the week of homecoming. So that's in 2 weeks. But you can go ahead and start bringing your posters. Thanks.
All right. How many of y'all noticed that this was exactly the same 2 sets that we wrote up here? A prime and B prime. We did the same A prime and B prime up here. So, we just sat there and reworked them. But at least we came up with the same answer. So that shows we have some skills, right? So, let's see. Lane, can you help me get, well, first of all, how do I say this? What does this want me to do? A prime. Union. And what does union mean? Put them together. Yeah, but don't double list something. Okay? So, looking at that, how would you organize that? Huh? What did you say?
11, 13, 15, 14.
Okay, 14's good. Does order matter? Nope. So are you kind of blending them as you go, or are you just gonna copy the big one and then see what's left?
I'm gonna go in order.
Okay, so we're kind of in order, right? Then what? Yeah, so the union means I need all of them. Yeah, 16 and 18. So at first it's not just what they have in common, it's everything. Yeah. So, but in this one, we don't have to look at the universal set. Okay? We had to look at the universal, unless we noticed that we did it before, but when you got them, we had to look at the universal set to get the prime in the first place. But to get a union, we've already got the complements. Are they the same? It's this one. Not exact order, but the same. So, once again, De Morgan's law appears to be true. So, we're not proving it's true by trying it in one example. We're verifying it, but De Morgan had to actually go through some huge amounts of proofs to prove that in all cases it would work. We've just verified that it works in one case. All right, and you may be verifying that it works in a few more cases as you do your odd problems. All right, so moving a little further, determining the cardinal number of a union. Y'all, What's a cardinal number?
How many elements?
Nicely done, gentlemen. The number of elements in a set. So, what's the symbol when you need a cardinal number? Looks like the absolute value symbols, doesn't it? And so your answer has to be a number because you're counting how many elements there are. So sometimes it's helpful to create the set that you are getting the cardinal number of. If it's a union, you need to create that set. So what would be in the set of A union B? And don't look up at the top of the page because I've given you a new A and B, haven't I? Now, what's the one word that needs to pop in your head when you think union? I would go with the word everything. Union is everything. Okay? Intersection, what's the word that should pop in your head? Common. Okay? So, if I'm creating a union B, I need everything. But what if they have stuff in common? Yeah, don't write it twice, correct? So, Sully, help me create a union B. 1, 2, 3, 4, 5. I might as well copy a whole list with the union because I know it all belongs there. And then I come over here and say, what else? Oh, I've already got the 2, already got the 4, but I don't have the 6 or the 8. All right? So, let's see. Aiden, help me with this. What is this asking me?
For the cardinal number.
Of the set we just created.
Yeah.
So what would that be? 7. Nice. Okay. I have a little flashy note. Remember that you don't need to list the same element twice. Huh? Gets kind of busy, you think? Okay. So there's a rule called the principle of inclusion or exclusion. PIE. All right? This gives us a way to maybe not have to create the whole set. We just did an A union B and got the cardinal number, right? You could avoid writing out the set A union B by using this principle of inclusion or exclusion by just, instead of rewriting a new set, finding, what does it say you could do? Finding first what? Finding the cardinal number of the first set. So it may be easier than copying the first set and making the union. You're just counting the first set, right? And then what else are you doing? So you're counting the second set with the cardinal number. But then you may have counted some things twice, right? So you want to exclude anything that they had in common. And so that may be quicker for you to do. So let's flip back here and see if we could use that principle of exclusion. It said A union B's cardinal number should be equal to, we just looked at it. How much of what we just looked at can you remember? What did it have you do? Not A prime. Cardinal number of A plus the cardinal number of B minus the intersection of A and B. So if we were looking at these sets, let's try that out. What is the cardinal number of A? How many elements does it have? 5. How many elements does B have? 4. But how many of them got counted in both lists? So there's 2 that they have in common, with the 2 and the 4. So they actually got counted here and here. They were double counted, weren't they? So we don't subtract 4. We only subtract 2 because we're leaving one of the countings. It needs to be counted once, just not twice, right? So minus 2. So what does this math come up to?
7.
There may be situations where it's a lot easier to just count the cardinal numbers than create the union and then count it. So let's try that out. So that's what that is saying. And this little piece right here prevents double counting of the elements in common. Because A intercept B is the elements in common, right? The cardinal number of A intersect B is the number of things that got counted twice, so just subtract it and you didn't count them twice anymore. So, this next little bit, we are going to talk a lot in this class about standard decks of cards. They are used in mathematics a lot for sets. They're used some in logic, and they will be used again in probability, and you need to be familiar with what is in a standard deck of cards. So, it occurred to me last week that I really needed to have a nice handout for you of what's in a standard deck of cards. So I created that, and then I also went, and for next year, I've actually inserted it so it's in the notes packet. So, if you're sad that your standard deck of cards is going to be on a separate sheet of paper right now, then fail and come back and take this class next year, and you'll see that I actually have it inserted into the notes document. This is a work in progress, these notes are. Alright? We need to make sure you understand. How many of you are pretty familiar with what's in a deck of cards? Let me ask some questions, see if you can answer them. How many suits are there in a deck of cards? 4. What am I talking about? What are the names of those suits?
Diamond, heart, club, spade.
Diamond, heart, club, spades. Y'all agree? When I was a kid, I thought the club, the puppy feet. Yeah, I call them puppy feet. Anyway, what colors are the cards? They're considered blacks and reds. So you have some suits are black cards, some suits are red cards. How many cards are in each of the 4 suits? 13 in a suit. Yeah. Now, if there's 13 cards in each of 4 suits, how many cards are in a standard deck if you exclude the joker? 52. You ever played 52 card pickup?
Yeah.
Or actually, you would probably prefer to be the obnoxious person helping your little brother learn how to play 52 card pickup.
Yep.
All right? So, let's make sure, just in case, because occasionally I get students who aren't super familiar with these. All right, this first suit that has hearts on it, guess what they're called? These are your hearts. Okay, but you know what? I think I'm going to change that I'm doing that with a red pen. But, I mean, if you have a red pen, you may want to employ it right now. But if not, we'll just write the word that hearts are red. But I think that I should write it in red. Hearts, the symbol is a little heart, which is kind of self-explanatory. And below it, we have this shape that's called what? Diamonds. I don't know why they don't call it rhombi, because it's rhombus, but nope, they call it a diamond. Your hearts and your diamonds are your red cards. So, that's half of the deck there is red, correct? The deck has 52 cards. There's 13 in each suit. How many red cards are there? 26. Good. The rest of the cards are the black cards. So this symbol, which looks like an upside down heart with a little tree stand on it, is called a what? A spade. It does not have an apostrophe right in the middle of it. That's an error on my part. Clean that up, clean that up. Okay. And this one is not officially called puppy feet. But do you see why some people call it puppy feet? Kind of looks like a puppy dog footprint, but it's got a little stand on it. What's it called? I have no idea why that's called clubs. Okay? Sometimes a spade is a type of shovel that's sorta, kinda shovel shaped, sorta. I can get the diamond, I can totally get the heart. What the heck is a club? I don't know. You know, if you're looking at these from having very long history, a club would, might be something you beat somebody with. I still don't see that. You may join a club. I don't see it. But these are black cards. I need you to keep up with this little page because we'll have this come up again in the subsequent units. For sure, you'll have a lot of questions and probability when we get to that unit. So, keeping this in mind, we are going to be answering some questions here. So, example 1. It spells out what we've got. So, see if you agree with this. A standard deck of playing cards has 52 cards, right? 26 are red, 26 are black. They are divided into 4 suits: the clubs, the spades, the hearts, the diamond, where there are 13 in each suit. There is not a 1 card, is there? There's an ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. The face cards are the jacks, queens, and kings. So, you know why they call them face cards? They have faces of a jack, a queen, and a king on them. Although aces in some games go high, and so like an ace may be more valuable than a king, it's not a face card. All right? And sometimes you'll hear aces are low, which means they count more like a 1 instead of something even higher. So, that information, this little deck of cards, y'all's doesn't have this printed on it, does it? Oh, wait, never mind. It's not printed. It's just sitting there. Like, when did I get this printed on that page? Literally just laying in front of me. Okay, in that humbling moment, let me move on. Find the number of cards in a standard deck that are either clubs or face cards. So here we are now getting into a word problem that is asking us to either find an intersection or a union. We have been given clubs or face cards. Do you remember what that or means as far as deciding if it is an intersection or a union? Okay? It could be either one or the other, right? Is that a union or an intersection? It's a union. So, in a union, what does that mean Venn diagram wise? How much am I shading for a union?
No shade either A or B.
Okay, so I'm shading the entire A and the entire B and the things they have in common, right? So, this is, I could call that A. I don't know if you can see it. I'm writing it over something I already shaded. Maybe. This would be a union B. Union is associated with the word or. Somebody the other day, one of you guys the other day asked about, we see those words. When they are just giving you a sentence and they're not listing sets for you, then that keyword or is going to let you know I can either be clubs or face cards. So pretend that I've got a deck of cards in my hand, and I come right here in front of Stephen, and I say, draw a card. You will win a piece of candy if you draw a club or a face card. So what could he draw that would help him win? Any club would do. Any face card would do. Is it possible that he could win, but he's drawn a diamond?
That's a
Queen
face
of
card.
diamonds. Yeah, so it's a face card. What if you drew the two of hearts? Could he win? What if you drew the two of clubs? So we need to count everything that is a club and everything that is a face card. Are there some of those cards that may be double counted then? There's some face cards that are also clubs, right? So we don't want to list those twice. So our instructions were to find the number of cards. Y'all, if they want the number of cards, my answer is not the set itself, it's the number in the set. What do we call that? Yeah, we're looking for the cardinal number of these cards. So, we can first find out how many clubs we've got. We could find the cardinal number of clubs. So, according to this sheet, how many clubs are there?
13.
Okay, and you might even want to at the end say 13, 13, 13 for each row. So there are 13 clubs. How many face cards are there?
12.
Ah, how are you coming up with 12? I only see 3.
But there's only 3 clubs.
There's only 3 clubs, but the spades have them and the diamonds and the hearts. So do you agree that there are 12 face cards?
Mm-hmm.
Okay, so how many got double counted? Okay, how many? Okay, so the intersect is how many are double counted? That's what an intersection means. Okay, so let's just take a look. How many of the cards that I counted first, let me see, maybe I can slide it up above. Just fold back this extra spot. When we counted all the clubs, we counted this row across, didn't we? When we counted all the face cards, we counted these 3 columns all together. What got into that intersection? The 3 face cards that were clubs, right? Clubs that are face cards. So, this sentence here says thus. The cardinal number of A union B, because doesn't or mean to a union, could be figured by getting the cardinal number of A, which we have a 13, right? Plus the cardinal number of B, which was 12, minus the number they have in common, which is 3. This might be easier than having to list everything in the union and then looking for the cardinal number of that list. Okay, so 12 plus 13, what's that?
25.
Okay, so we're looking at 25 minus 3 gives us how many?
42.
All right. How do I know that works? How do I know that's good? I can think of 2 really good answers to that question. How do I know that's good?
You can do the other side. Like
Okay.
you can find the card number of each person like that instead of everything.
Yeah. How do I know it works? Okay, 1, does this make common sense? I count all of them in the 2 separate groups and I just think how many do they have in common that I just double count and I subtract it. Common sense. Plus, it is this principle of inclusion rule that says it works. All right, another example. Example 2. Find the number of cards that are either a 2, 4, 6, 8, or 10, or they are diamonds. But when I'm saying find the number, I'm not asking you to make me that set. In fact, how would you list that set? Would you have to write 3 of diamonds, 3 of hearts, 3, or that would be a long list to make, wouldn't it? But we can use the principle of inclusion. What are our 2 sets here? Okay, why don't we call that set A? All right. What's our other set? All the diamonds. Set B. And what does this word tell me I want to know if it says or? The union. So I'm looking for the union of set A and set B. Well, how many are in set A? Oh, hang on. How many are in set A? If you just look at this, you might think that that's set A, but notice that's not a set. It's got parentheses. That's saying, look at the 2, 4, 6, 8, 10s. If we look at the whole thing, I've got 4 of the 2s, 4 of the 4s, 4 of the 6s, 4 of the 8s, 4 of the 10s, don't I? Okay, so I have the cardinal number of set A is 20 because A equals 2, 4, 6, 8, 10 for all 4 suits. So I might put a little star there and a little star there. We're getting that 20 because it's 5 cards counted 4 different signs, right? Plus, we need the cardinal number of B. What is B looking for? Diamonds. How many diamonds are there? 13. But we don't stop there. Because what do we need to exclude? We need to exclude, tell me set-wise, what the intersection of A and B, which means how many of the 2, 4, 6, 8, 10s were also diamonds? 5 of them. This 2, this 4, this 6, this 8, this 10 got counted with the diamonds and got counted with the 4 separate 2, 4, 6, 8, 10s. So that's where we will finish up tomorrow. And that answer is the end of our 2.3 notes.
Did you end the recording?
I have not yet. I was considering it. Let's see.